So good afternoon. First, an announcement. The organizers has asked us to make this a presentation for general audiences, so we have to tone it down a bit, but hopefully you'll enjoy it. Anyway, my name is Adriana Subiri, and I lead the Big SQL engineering team at IBM. And with me is Nick Berg, who's the Director of Analytics at Seagate. Last year, I came to the summit to present the challenges of building a SQL engine on Hadoop and how to make it enterprise ready for customers. So this year, I thought it was a very good idea to bring one of our main customers to actually share with this audience what is a real life scenario and experience on how to use SQL on Hadoop to be able to do analytics in their company. So Nick has accepted to come with us and present to you, and also talk about how the thoughts about SQL have been evolving and how we're really pushing the limits on it. So I'll pass it on to Nick.
Okay, thank you, Adriana. So I just want to tell you a little bit about Seagate. Hopefully most of you know Seagate. We make hard drives. We've been in business for well over 35 years, and we've been putting a big marketing campaign and focus in the San Francisco Bay Area, so a lot of you may have seen our ads. And the reason we're doing that is we've kind of rebranded ourselves. We've got a new logo. We've got this cool new moving logo as well. And we've made a variety of acquisitions over the last few years to expand our portfolio of products into not just hard drives, but into flash and storage systems and storage services and consumer devices. A little bit more about our company. We're a pretty large company. We're about $14 billion annual revenue. Just recently, we shipped our 2 billionth disk drive. We have about 52,000 employees spread over 26 countries. And we have 9 manufacturing plants in the US, China, Malaysia, Northern Ireland, Singapore, and Thailand. And then we also have what we call design centers, which design the products, also in the US, Singapore, and South Korea. We manufacture pretty much everything in the hard drive ourselves. So we have a lot of factories that are vertically integrated. And if you didn't know, a head of a drive is actually made from silicon. So we do wafer fabrication, much like companies like Intel. Recent acquisitions we've made are LSI, which have expanded us into flash, Xaratex, which are high-performance computing storage systems, eVault, which is a cloud sort of hybrid solutions, and then branded drives, the C. So let me talk about Hadoop. So usual question is when people want to get started with Hadoop, where to start? So the usual answer to that, of course, is find a good use case. So I wanted to take you through what we did is we sort of chose different use cases and decided where should we get started with Hadoop. So first of all, we experimented with text analysis. This is going back about 2 years ago, where there's a lot of focus on social media analysis using MapReduce. And so we did a sort of a POC on that. We proved out that we could actually run through some text analytics using MapReduce and some machine learning through our call center support logs. And we presented that to our call center, and they said, yeah, that's really interesting, but can you go and do these 100 other things that we need to do too? And we felt, well, that would be a lot of development, so maybe there's already a solution for that. And in fact, there was, and they went out and purchased it. So that was our first try. Then we moved on and talked to our marketing organization, because, of course, we use Facebook at Seagate and Twitter and a bunch of social media. And we asked them what they were doing with that. Well, they had already outsourced all of that analysis to some external companies, and we were very happy with the support. So there wasn't a lot of value add we could see doing there. Then we talked to other people in the company, especially in IT, in our data centers, to see if we could help with their support logs, performance logs, maintenance logs. And in e-security, we're really also very interested, but that didn't really catch it for us. So we thought about this a bit more and thought, well, what is our big data problem? Our big data problem in Seagate is our manufacturing data. So we ran another POC using some of our factory test data, and ran some analytics on that, and that was pretty successful, and we thought, well, yeah, okay, this is probably the way to go. So why were we thinking that? Well, we have an EDW like most other corporates do, and that's a really sort of pressured system nowadays. We're constantly having to manage the storage in that. As you know, data is exploding. Here's some metrics that you may have seen published. You know, we hit 4.4 zettabytes of data in the world in 2013. 85% of that was coming from new data types, which is growing still. By 2020, 15 times more machine data. And within 7 years past that, 4.4 zettabytes will have grown tenfold to 44 zettabytes. So a real explosion in data. So you're not going to be able to really deal with that much data, as we know, with the traditional data architectures and systems. So we need something new, which is, of course, Hadoop. So what we decided that we would do is we would focus mainly on what we call the enterprise Hadoop cluster as an extension to our data warehouse. We have a need to store and analyze much more data than we currently can do, being quite constrained in our EDW. So up to 10 to 20 times the amount of factory and field data. And we also want to keep that data for much longer. We're really challenged with that. Our high volume data we can only keep for about 15 weeks. And then we also want Hadoop to be multi-tenant or multi-purpose analytic environment, which could be capable of supporting hundreds of users within our engineering, manufacturing, and quality organizations. That's at least the initial focus, and then once we get past that stage, we'll expand out into other organizations in Seagate. We also thought that perhaps we should have potentially some local factory Hadoop clusters, and we do actually have a few of those for some special processing needs. And then we would like to eventually integrate these all together so that we can pass processing jobs between these multiple clusters. So at a real high level, kind of the usual story, we wanted to ask much bigger questions about much bigger data volumes than we could ever do before and do analysis on those. So when we first started our Hadoop journey, MapReduce was really the main way to access and query data. But 2 years on, as you all know, the Hadoop world has really changed a lot, and SQL really being the major force in analysis on Hadoop. Why use SQL on Hadoop? Well, we think some very good reasons are it really addresses a skills gap where, if you want to use MapReduce, you're going to have to code in Java. You may not have an awful lot of Java coders around, but you've probably got people who know SQL. And within Seagate, a lot of our engineers know SQL, a lot of our power users use SQL, so it gives you a good entry point and addresses that skills gap. Also, SQL provides integration to all your other systems, so your relational databases, your EDW, your BI tools all know SQL, so why not use SQL on Hadoop too? And then finally, it enables Hadoop to move from a batch processing to more of an interactive analysis paradigm. So there are lots of new advances in Hadoop with new memory-based Apache projects such as Spark, but even Spark is now looking towards SQL to help out with that too. So what we did in Seagate is we put together a 5-year sort of vision statement and strategy plan about where we saw the use of Hadoop being used in Seagate, initially to answer this factory data and manufacturing data big data problem that we had, but then spreading throughout the enterprise. And we socialized that plan around and got some feedback. But we thought that really what we need to do here is we've done some POCs, but we really want to prove that Hadoop is going to be the data platform of tomorrow for us, because we're planning to put a lot of resources into it and a lot of effort into it. So we said, what we need to do? We need to do what we called a large-scale pilot, where we won't just go and get a few nodes and do a POC. We went out and bought 60 nodes. 3 of those being management nodes and 57 data nodes. We then moved on to the next question, saying, well, we got all the hardware in, but what software distribution are we going to use with Hadoop? Because there were a lot of choices back then, and it's consolidated a little bit now. And then finally, what use case to actually run in this large-scale pilot. So let me give you a bit more information on each of those things. So first of all, choosing a Hadoop software distribution. In our view, there's sort of 2 main flavors. There's vendors that have more of an open source oriented stack, and then there's the more proprietary distributions. And it has changed and consolidated recently, and Adriana will talk a little bit about that too later on. But we believed at the time that open source really was the way to go, and they're much more beneficial because it allows your solutions to be much more portable, so you don't get tied into a specific vendor if things don't go so well for whatever reason. You can move your open source to another vendor. Also, being locked into a proprietary technology tends to be expensive, and you get into this sort of vendor lock situation, which is not very healthy. And then finally, on open source projects, if you have an open source platform, then it's very easy for you to integrate with other new open source projects, whereas if you're more proprietary, that could be more problematic. Some other important considerations, though, is you'd want to have integration with the relational databases in your data warehouse to do federated queries and other things. You want to be able to integrate with your BI solutions and tools and some other platforms. Then to look at the actual software distribution vendor itself, you want to make sure there's some good, healthy R&D investment there, and do they have a good support capability, and do they provide consulting and training services as well. So we actually chose IBM as our partner, and the primary reason for that is because we believe that IBM had the most advanced SQL add-on capability within Hadoop than compared to anybody else in the marketplace. And one other note to add is that we were not an IBM customer. We do have some IBM hardware, but we didn't have any other IBM software installed. So we chose this for that very specific reason. So you've probably heard of Gartner's phrase of a logical data warehouse. We do believe in this, where you combine your traditional data warehouses with your big data systems so that you can evolve your analytics capabilities way beyond where you are today. But Hadoop is not ready to replace an EDW yet. An EDW is really what I would call a good general-purpose data management solution, where you sort of produce all of your everyday business analytics. And a typical EDW like ours may have hundreds of data feeds and dozens of integrated applications and run thousands to hundreds of thousands of queries a day. And ours actually hit the top end of that. And Hadoop's really not just ready for that yet. That would be very difficult to do today, but we do see that having that kind of capability for tomorrow. So you still need an EDW. That's valuable, needs to be around. A lot of investment obviously made there. And as you know, Hadoop is much more specialized currently. It's less mature. And so we see it having just, even though we want it to be multi-tenancy, having fewer application integration points initially, running fewer queries at a lower concurrency rate than our data warehouse. Another way of thinking of Hadoop, if you go sort of into Hadoop into a sort of a fairly large cluster, or medium-sized cluster maybe, of 50 to 100 nodes, that's a lot of computing power. In fact, I would think of it as being a supercomputer. So if you think of it as a supercomputer, then when you look at the use cases you want to run on Hadoop, what would you use a supercomputer for? Well, you wouldn't use it to run your little reports and other things. You're going to do it for the really big problems. So think of Hadoop as a supercomputer as you start to think what you want to do with it. So I wanted to share some of what Gartner refers to are not best practices, but early practices. I kind of like that phrase, because we're still learning, and some of the learnings that we had along the way and what we think are good ideas. So when you do choose your initial use case, we suggest that you don't do a huge big bang project. You want to do this incrementally, or just do it use case by use case. We chose the incremental phase delivery, where we do have a fairly large project where we're bringing in all of our manufacturing data from around the world, coming via our EDW initially, but then loading additional data on top of that, and delivering that in phases. We do believe in the concept of having a data lake or data reservoir for all your enterprise data, so we do plan to load into Hadoop everything that we have, but not make it into a data swamp. I think you need to think carefully about should that go in there and how should it be structured. Another issue we have with EDW is we don't really have very good data latency, because we go through the traditional steps of gathering requirements for new data sets, understanding what those are, building a data model, building the ETL, and then eventually we may do some analytics, but that takes a long time. And the problem with that is the data doesn't become available very quickly. So with Hadoop, we believe data availability must come first. And then once you bring your data in its raw format, then you can then model that and transform it. But do that in place. Resist moving data out of Hadoop. You want to keep it in that data lake. Also, there's been lots of discussion about, hey, it's really good to do schema on read, But that's really not practical for a data warehouse type of application. You do need a data model. The data model can be simplified. You don't have to have a full sort of Kimball-based data model that you may have in your warehouse. It's going to be much more flatter than that and denormalized, but you still do need a data model. So schema on read may help for some things, but not for a general purpose sort of data warehouse type of application. The other thing is you need lots of clusters. So we started off with one 60-node cluster, but then we quickly realized, well, we've got a bunch of developers, and we don't really want them developing on the 60-node cluster, so we better get a development cluster so we can keep them developing. And then we have lots of upgrades to do, so okay, we need a test cluster so we can test upgrades, and we don't want to disturb those developers. But even with production, we believe that you need more than one production cluster, because the technology is so immature at this stage, it's very difficult to have all your users with all the different types of workloads and capabilities working together and have a stable single cluster. It's very challenging. So as things mature, we may be able to do that, but currently today we have two clusters. We have one 60-node cluster for our data scientists and power users to do data exploration and experimentation, and it's kind of a free-for-all. We don't mind what they do on that. And then we have another cluster that's a 100-node cluster, which is more of a sort of a batch scheduled type of cluster where we can provide guaranteed cluster availability and start to introduce some SLAs on that, which we wouldn't be able to do if we had everybody with a free-for-all on there. And then finally, another decision that we made was that we didn't want to put our data into Hadoop and then go and figure out how to develop applications around that. We wanted to fast-track that. So as we're using SQL and big SQL, it's easy to take one of your applications and basically integrate it into or transplant it into the Hadoop world. And that's exactly what we did. We took one of our key corporate applications that does a lot of queries out of our warehouse and runs some analyses on that, and we ported it over to Hadoop pretty easily, actually. So that gave us the ability to provide transparent access to our users. Another thing that I've seen talked about in the early stages, but not so much nowadays, but I think it really holds true, is you want to think about having your data in Hadoop in partition format or in tiers. So we all talk about Hadoop storage being cheap, and it is cheap comparatively. So you can tier your data, and the way that we do this is that we want that real low latency to get data very quickly into Hadoop, whether it's streaming or brought in from our warehouse using Scoop or whichever other method. And we bring that in right away, and that's available for our data scientists to use immediately in that raw format if they know how to. And then a second tier on top of that, where we're essentially duplicating the data, is where you want to start to model that data, structure it, transform it, maybe dedupe it. And that's where the majority of your users are going to be, because they want to use that type of data. But that introduces some data latency to get there. So that's what we call tier 2. And then tier 3 is another tier above that, where tier 1 and tier 2 is, tier 1 is your raw data, tier 2 is your sort of model data, but that's your most granular data. So tier 3 is sort of for more specialized analytic data sets, where you may have different types of roll-ups and aggregations and pivots. And then potentially even having a fourth tier, we haven't quite got there yet, where you may want to start thinking about, well, do you want to start to have extended history and archives, and perhaps put that on some kind of cheaper hardware where it's not quite as high performing. Again, we haven't quite got there yet because we haven't filled up our clusters of data. Another best practice or early practice that we see is, as your EDW is connected to all your BI tools and applications, as you start to run some analyses on Hadoop and you come up with a result set there, you may want to just move that back into the EDW so that you can use those very same tools, BI tools, on that data set. Throughout the whole process here, you need to do lots of performance testing, running benchmarks, and try to continually optimize the system, because things are changing very fast all the time, and it's amazing what one small change can do. So you have to be pretty structured about this and say, okay, this is time that we need to test what this change is going to do and see how our performance is running against our regular jobs. So here's a sort of real high-level diagram of our architecture. We are a Cisco shop, so we use Cisco switches, and right at the top there, you can see that we have a couple of aggregation switches. These are very low latency switches. We actually initially bought some different switches and then had to move to something more scalable and low latency with some redundancy there. So if one switch goes down, the cluster doesn't go down. And then each pair of clusters has redundant switches connected together as well. So if a switch goes down in a cluster, it will still continue to run because the paired one next to it will run. So rack 1 and rack 2 are paired together. Each rack has 20 servers in them. We use two 6-core servers, and we have about 140 gigabytes of RAM loaded on those. So fairly well spec'd. And as you can see, we have racks 1, 2, and 3 with 60 nodes, being our sort of ad hoc cluster for data exploration and data experimentation. And then we have our sort of other production cluster of 100 nodes from rack 4 to rack 8, which we can provide that guaranteed cluster availability. And then rack 9 is not using redundant switches, which is where just our dev and staging or test clusters sit. So a couple of slides about challenges. Lots and lots of challenges, as you would expect with this new type of technology. I think things have really started to improve now, but early on, the Hadoop development community was extremely fragmented, lacking standards on an open platform, and that's really not good. And we certainly would like to see more standardization there. One of the problems that crops up with that is that if vendor solutions don't have good interoperability, if you don't have some standards in place. Then there's new Hadoop projects cropping up all the time, and you need to kind of look at those projects and decide, well, am I going to bet on that project? Is it going to be around in 6 months' time, or is it going to die off? Because that does happen. So I would say don't try to be too bleeding edge. Choose carefully, wait for a project to mature to a good point, and then jump on board, because it may die and wither away. Then the speed of change. I think Hadoop is probably having more code being written for it than any other IT platform, and just the speed of change is incredible. So it's very hard to keep up, and we find that we need to upgrade our cluster very regularly, with at least once a quarter, or more often with updates, which is something that is kind of new for us, especially at this kind of scale. Hadoop is still fairly immature. Things aren't quite ready yet. Rogue column security, lots of improvements have been made there, but again, probably not at the level that we run on our data warehouse. And real-time queries, the same kind of thing. You can do real-time queries on very small data sets, but Hadoop is a big data system, so try and do a real-time query on big data. It's not going to work. So there's some more work to be done there. And then just generally resource management. As I talked about, we split our cluster because we recognize that the resource management isn't quite there yet, where we can really comfortably control real sort of ad hoc processes, someone taking over the whole cluster, and then still having production jobs that we want to run within an SLA. So I think there needs to be some more work done there, and Yarn is making some good leaps, but it's really not to the level that it needs to be in order to accommodate these sort of the wild west of types of uses that users will do on your cluster. And then we do have a few BI tools evolving around Hadoop, and it's good to see that they're sort of moving away from the initial type of solutions where they were just pulling data out of Hadoop. That just seems counterintuitive to me, because the whole idea is you want your data in Hadoop and you want to do your processing inside that compute engine. So why pull the data out and do it something separately? So we are seeing some vendors now are starting to retool with that, using things like Spark. But try and find a tool to visualize big data sets. There isn't anything. So there are some evolving things coming out of universities, but if you really want to visualize big data, there isn't a solution right now. Try and point Tableau, for example, at a big data set. It's not going to be able to handle it. This is largely being addressed now. So Hive tables were only sort of write-only and no updates allowed. and not being ACID compliant. But the latest versions of Hive have started to correct that, which is good. But Hadoop is still very much batch processing oriented, as I mentioned before. So interactive is gaining traction. It works well with smaller data sets, but we don't think it's really quite enterprise ready yet, especially for big data sets. Provisioning large numbers of machines and dealing with hardware failures is again, a new challenge for us when you start to go to somewhat of a scale. And it can be very difficult when you have a hardware failure to figure out, well, what's going on with my cluster? It's not working. Where's the problem? And with hardware failures in particular, they can be very much disguised before you realize that that's what's going on. So you need to have lots of monitors out there and good systems to tell you if some hardware starts to give some problems. And then, as I mentioned, that we do plan to have an enterprise Hadoop cluster as we do in our main data center, but we do also recognize the need for local clusters, and we have a few out in Seagate. But right now, there isn't really a good way of integrating those clusters, and that technology is starting to mature. But if you want to do sort of inter-cluster processing, that's a little bit difficult to do nowadays. So that's another challenge for us as well. Another challenge that we have is just setting expectations. So just for IT ourselves, this is a completely new technology. There's so much to learn here. And when you start to implement a larger cluster, like a 50 or 100 node cluster, you need to put a lot of design and implementation into that. And those are huge tasks. So you need to really consider having enough time to put all that together. As I mentioned, Hadoop is still pretty immature. It does lack robustness of what you'd see out of a data warehouse, which is running on technology that's been around. Ours is based on Oracle. So Oracle's been around for, 30 years. Hadoop really hasn't been around that long. So you have to expect you're going to have a bit of a buggy system, some instabilities, and just share that with your users and management to say that that's just the name of the game, and we just have to live with that. And also, in my opinion, just there's so much change going on that I think new code is being released much too quickly, and it's all the cool new things that you want to use, but I think it wouldn't be a bad thing if it slowed down a little bit to allow that code to really sort of mature and be tested well. I talked about the speed of change, which is huge. And because of the speed of change and the fact that things do change, you'll make plans, but those plans have to be very dynamic. And you have to sort of convince your management that things are going to have to be flexible in terms of when you start to plan things out beyond 6 months' time. Also, the same thing with your schedules, because you're going to have these issues that come up with this less mature technology. You're going to put out a plan and have some goals there, but quite often you're going to miss those for whatever reason. And so you just have to, again, explain to your users and your managers that you're going to have less sort of flexible schedules and less formal schedules than you would have with another typical project. And it's kind of tough to move hard enough because there's a lot of pent-up expectations here from your management, from the power users and the data scientists who want to get onto the cluster. So another thing that you have to set expectations amongst your team is that things are going to change within the technology. So you may be following down one path, and then perhaps some new project comes out that looks very promising, and then you may decide to change tactics. So, and you may have to redevelop in some areas and perhaps even throw away some code. So it's good to experiment. There's this concept of failing fast. So, picking up and experimenting something and seeing how it works. If it doesn't work so well, then let it fail, move on, and try something else. Another huge challenge for us was we came into this not knowing Hadoop at all. So we tried to hire in some help with some consultants and bringing in some talent. And while there is some talent out there, it's very, very competitive, as you've probably heard. So it's really difficult even to hire in consultants who are really good, who've actually put in a production system. And that was basically what our interview process was for hiring people is, what have we actually done in production? Because most people have done POCs, experimented, but to find someone who's actually done a production system or two is pretty rare. So that was a big challenge for us. And then finally, just something, because we're a large corporate IT organization, one of the big challenges we had was convincing our security teams that it was really okay to give users a Unix account, because this was kind of unheard of in Seagate. And we spent quite a long time, and we had to go up to our chief security officer to convince him that this had to happen. So we finally got that sign-off. So that's just sharing some of our experiences with you, and I'm going to pass it now back to Adriana.
Thanks, Nick. So one of the things that you heard Nick talking about when talking about challenges that they're experiencing is vendor lock-in and interoperability. And that's why we have decided in IBM at the beginning of this year to actually change our strategy in terms of what are we doing with our open source distribution. And where before we had some proprietary code, there we have decided to move on and have 100% open source based distribution. So, and that distribution is based on the Open Data Platform. This Open Data Platform, I assume that most of you have heard here at the summit, but a consortium that we have formed with many different companies, including Hortonworks and Pivotal. And the objective is really to be able to provide some standardization across the core components of Hadoop to allow vendors to be able to have a stable platform where they can actually develop and make that solution portable across those distributions. And one of those solutions is Big SQL. Big SQL is a SQL solution on Hadoop, and that when we started looking at it, we realized very, very quick that one of the main things we wanted to have is very rich SQL. The expressiveness of the language here was key for us, because one of the things that customer wanted to do, as actually Nick mentioned, is really to bring some of their existing SQL applications into the world of Hadoop without having to have to modify their code or go into expensive application migrations because of the limiting SQL expressiveness you have. So at our core, we were able to provide the same SQL that you can have in any data warehouse. Of course, important for us as well, and that makes a little bit different than other traditional database vendors, is we decided to be completely open. We think Hadoop ecosystem is about interoperability, so we don't have our own proprietary data formats. So you can have any data formats you want, and Big SQL being the engine can access that, being Parquet or C, text, whatever. So we think that that help us, showcase that we don't have this vendor lock-in. Performance at the core as well. Everybody on SQL and Hadoop claims to be the fastest SQL engine in the market. Last year in October, we published the first audited benchmark on SQL and Hadoop, showcasing that we are the fastest, has not been challenged ever since. And it's out there for everybody to know about details. But we continue to invest, and the reason we were able to achieve that is we haven't reused a technology that IBM has been developed over the decades that we have been doing SQL, and we have been able to apply it into the world of Hadoop. Another important aspect here is federation, and this is important because data warehouses are there to stay. Maybe there are different use cases where they actually will expand. We have customers doing data warehouse augmentation. Other customers are bringing parts of the data warehouses into Hadoop, but the data warehouse keep being there. And customers want to be able to issue queries across, where they can actually join data from Hadoop or Oracle or Teradata, whatever is the warehouse that they have. So providing these capabilities within Big SQL is something that we think in a SQL solution on Hadoop is key. And of course, we're bringing a very mature SQL engine, so everything that you expect from the enterprise perspective is there as well. So what's coming for us? I thought I would share. First, it's important to know that we don't handcuff our customers. We are very, very open, especially now with our open data platform and open file formats. We are planning to support in the second half of 2015 other ODP compliant distros, including Hortonworks. Last year was probably the first question I was asked here at the summit is Big SQL going to support Hortonworks? So we said we're working on it. This year is yes, we are. We're going to also support not only Linux on Intel platforms, but on Power and on Z. Even though we are still having our audited benchmark unchallenged, we're still going to introduce major performance improvements in the second half. We think this is very important to really stay ahead of the competition. Another important point, many of you, of course, have been here about Spark. Spark is a very interesting technology, and we want to exploit this technology. We want to integrate with it. So we will be able to, whatever today you call Spark SQL, create also a context. You will be able to create a context and call big SQL instead, and be able to leverage the power of our SQL engine, not only in the expressiveness of the SQL, but other features that you have, like federation, security. And also customers that are actually working on SQL and want to call an application on Spark will be able to do that through a user-defined function. So you will be able to actually call a Spark application and get RDDs back and continue your processing in SQL if that's where you want to go. So these are not, many people ask, are these competitive? I mean, are we in direct competition? And I don't think so. I think that we are complementary in that sense and working again on the roadmap for 2015. We're also doing further enhancement to the user interface. We got in 4.0 now in March, a very nice user interface. We're doing further enhancements to it. Always working on better SQL compatibility with other SQL engines. We want transitions from wherever SQL engine people come from to make it very, very easy to come to big SQL. We do have H-based support. Today for select and insert, we're adding update and delete. We're also going to support Hive asset update delete. As you saw, it's a requirement that is very important to customers, particular. Nick was one of the first questions he asked me this year. When are we going to support that? And always analytics enhancements. We actually have a lot of in-database analytics and will provide user-defined aggregates. So this is all we have, and we have a few minutes still to open it for questions. So if I want to ask questions, Nick and I are here to answer, and if we run out of time, we'll be outside as well. Yes?
For your roadmap on big SQL, do you have any plans to support nested data type formats like JSON or lookups?
We are actually considering now, we actually support, we supported in our March release nested types, but in particular JSON right now, we don't have it in the roadmap for 2015, but we're definitely considering that. There are ways where you can actually work with JSON formats. In our Hadoop Dev website, we have a paper on how to work on that. It's not native in the sense you cannot do it in a create Hadoop table, but there are ways to work on it. Yes? For what, sorry?
Are there any plans to open source this piece, Big SQL?
To open source Big SQL? No, we have no plans. You had to think, Big SQL is based on existing technology, on database technology we had for many years. So we don't have any plans to open source it. Okay. Well, thank you very much for coming.
Thank you.